In this section, we're going to cover a concept called solving systems of linear equations. Technically, this should be review. You should have learned this in your previous algebra courses. But I'm going to go through it just in case we need a little refresher, because this is kind of the backbone for the entire course. So please make sure you really have a thorough understanding of it, because it's really important for what we're about to do. Okay, so a system of equations, we have three different techniques for solving a system of equations. And if you don't remember what that is, a system of or linear equations could be any set of equations like 3x minus 3y equals 4 and y equals 4x plus 2. Just made them up out of thin air. It would say solve the system. And so it would look something like this with a set of braces around it. Okay. So we have three techniques. We have the elimination technique, which just says arrange your system so they are in the same order. So the x variables are lined up with the x variables, the y variables are lined up with the y's, and the equal sign and the constant term are all lined up. So, and typically we would leave this one alone. We like having the variables on one side. And then for this other equation, I would subtract the 4x over to the other side, so that would give us a negative 4x plus y is equal to 2. Now that they're lined up, the elimination technique says what we're going to do is multiply one or both of our rows by some number, whether it be a decimal, a fraction, or just a nice natural number. You're going to multiply by some number other than 0, because if you multiply by 0, the entire equation will get wiped out. But so you're going to multiply an equation by any value, so that way you have a match. So I'm going to multiply this by negative 3. I'm going to multiply this side by negative 3. Actually, I'm going to do positives because that'll work better for us later. So even though it would be a match, what I'm going to go for is the opposite sign. I'm just going to jump ahead a little bit since this is technically supposed to be a review. So I'm hoping you can follow along with that concept. And if you can't, after one step, hopefully you'll be able to follow along. So if I multiply this entire left-hand side by 3, I'm going to get negative 12x plus 3y, and that's going to be equal to a positive 6. Now the elimination technique says when we add these together, the goal is that one of our variables will be eliminated. One of our variables will just kind of go away. So what would we be left with? So let's see. Negative 12x plus 3, we're adding the rows. Negative 12x plus 3 makes what? Negative 9x. Negative 3y plus 3y, those add together to make 0. And that's 0y, and that's when went away. It became 0. And then we get 10. So this one's gone. So we're just left with negative x equals 10, which therefore now we can solve, which would give us x equals negative 10 ninths. Is it okay that our answer is not a whole number? Is it okay that our answer is a fraction? Absolutely. Okay, we're going to deal with a lot of fractions in here. Very little in the real world is a nice, pretty whole number. We'll try to do a lot of examples in whole numbers in the notes just to make it easier to follow along. So you don't get lost with all the fractions and decimals, but please expect homework and tests to be not pretty. All right, so x equals negative 10 ninths. So now we still can go to figure out y. So what we can do here is take our value for x, and we're going to go back to an equation where we had solved for y, right? Right over here. And what we're going to do is take that and substitute it into the x value. So therefore, I know y is equal to, and here's the x value right there, right? So y is equal to 4 times negative 10 ninths plus 2. So now when I go into here, let's just solve a little bit of algebra. So this is going to give us a negative 40 ninths plus, well, let's get common denominators. So this would be over 9, so this would be what, 18. So now when I add those together, we're going to end up with y equals negative 40 plus 18 would be, I believe, negative 22 ninths. So therefore our answer, if you remember, is an ordered pair. It is not the x and the y individually, but both of them together. And we'll explain that, or we'll see that again in one of our other versions of solving. So this is negative 10, negative 22 ninths. There we go. So there is our answer. That is elimination technique. So what is the big idea in elimination technique? we're going to say first thing you do is get them in the same order. So you're going to line up your x's and your y variables so they're vertically above each other, the equal sign, and then the constant term. Then what are you going to do after that? You are going to multiply by a non-zero scalar. There we go. Multiply by a non-zero scalar. And then next, add the rows to eliminate. I'm going to highlight that. Eliminate. That's why it's called elimination technique, a variable. Okay. And then last, solve, right? Solve for the other variables. Okay, great. Elimination technique, wonderful. Substitution technique review. Substitution technique, let's go back to the exact same system of equations that we were just working with. Since we know the answers, it'll kind of help me make a point that I want to make. Substitution technique, same idea as elimination, same goal, but what we're going to do is instead of trying to line them up, what we're going to do is say, I'm going to solve for one variable. Now, this system that I wrote here is actually kind of perfect for that because we already solved for a variable. So all we're going to do is say, look, I've got a y. I'm going to take that and substitute it into the other equation. So that would give me 3x minus 3 times. Now, everywhere I have a y, I'm going to replace it with, I'm going to substitute it with 4x plus 2. That's why it's called substitution technique, because we're substituting. And that will be equal to 4. And the beautiful part of substitution, the whole point of it, is after you do the substitution step, that variable should be gone. There should be no more y's. And there aren't. So now, just using a little bit of algebra, I'm going to distribute my negative 3. So that will give me what? Negative 12x minus 6, which is equal to 4. So now when I combine like terms, we are going to end up with negative 9x equals, I'll add the 6 across, so that's going to give me 10. And last but not least, I'm going to solve, which will give me x equals negative 10 ninths. Now the good news, that's the same answer of what we just came up with. So then just like the last problem, we're going to take this, I have the x, I'm going to substitute it in. So therefore y equals 4 times negative 10 ninths plus 2. And once again, you solve exact same way. Not going to finish it because I'm recognizing these numbers. They look the same. So there you go. The big idea. Do you notice? Substitution technique and elimination technique gave us the same answer. They are two different methods for solving the same problem. So why do we need two different methods to do the same thing? Well, as you saw, this problem was set up very nicely for substitution. So you would choose this method, probably for using the substitution method, where if it was set up differently or the numbers were different, you might choose elimination instead. So this comes down to a critical thinking component of when you look at a problem, you're not going to memorize one particular method to do everything, but instead you're going to say, which method do I have that is most efficient and most effective? By the end of this course, we're going to have 5 different methods for solving these same problems, and you're going to hate your life if you don't pick the right one sometimes. They get horrible. Okay, so substitution technique. What is the idea? Step 1, and this problem already had it done, but you solve for a variable. And it doesn't matter which equation you pick. You could have used the top equation, you could use the bottom equation. They're just written top and bottom arbitrarily. It doesn't matter which one's on top. So you just pick whichever has the easiest variable to solve for. Okay, solve for a variable. Then step 2, sub into the other. That is key. Other equation. You can't substitute it back into yourself. You're not solving a system if you completely avoid the other equation. You have to use both of them or all of them. If there were 3 or 4, you got to use them all. Okay, then last but not least, once you substitute in, solve. Okay. Last but not least, this is the final version of this, which is graphing the equations. Now, we're going to graph a lot in this class, more just to get an idea of what's going on, and then we're going to talk about algebraic ways of solving or other methods of solving, and not being dependent on the graph. Because as your numbers get ugly, or as you move into, instead of a 2-dimension like we're doing right now with just two x and y, two variables, if we had a 3-dimension or a 4-dimension equation or a 5-dimension, graphing's out the window, right? So we're going to start with these easy to graph scenarios so you can visually understand what's going on. And then as we progress through the class, we're going to move to things that there's no way you could ever graph them or get anywhere close to an accurate answer when you're graphing. So you're going to want these other techniques. Okay, so graphing, the idea here is what we've got going on is we have two linear equations, right? We have two linear equations. And what we are finding is the x and y value where they are intersecting. This x and this y works for both equations. So if you go back and take these values that we just solved for with the x being -10/9 and the y being whatever it was, if you substitute those values into the first equation, it will equal 4. And if you substitute those values into the other equation, it's going to equal whatever y equaled, right? The x will make the y. So what we're doing is we're saying, I want the solution that makes both linear equations true. And that's the big idea. Okay, so in the next video, that's the big theory. So in the next video, we're just going to go ahead and do some. So we're going to do elimination technique and substitution technique and so on and so forth. All right, we'll see you in the next video.